Alrighty, first off, second period. I'm really sorry. I don't know why I said we had to use substitution. We don't have to. Because during lesson 13, 14, and 15 when we talked about it, we have notes. Let me pause real quick. Okay, so I found my book. It was lesson 15. We said that when we're looking at them, if they are parallel, there is no solution. So being parallel means they have the same slope, different y-intercept. So I'm going to write that on here. No solution means parallel lines which is same slope, different y-intercept. And our equations are in y equals mx plus b form, slope-intercept form. If there's one solution, the lines cross, which means they have different slopes. And infinite, they are the same line. Same line. That means their slope and y-intercept are the same. That was from lesson 15, unit 4. All right, so now let's go through and answer these. We don't need to solve anything, so I'm really sorry, second period, because we don't need to know what the solution is. We need to know if it has one or none, or infinite. So this is my slope. I have two different slopes. That means I'm going to have one solution. B, I have two different slopes. That means I'm going to have one solution. C, I have the same slope. So I have a slope of 3 and a slope of 3. So if I were to draw this, just a quick little sketch, one crosses at 1, one crosses at 7. Both lines are going to go like this. They are never going to cross. They have the same slope, which means no solution. Problem 2, or sorry, D. They are not in slope-intercept form, so I do need to do some math. I need to move some numbers around. I need them both in slope-intercept form. I have x plus y equals 10. Well, I need x on the other side. I can't minus my x from my 10. Y equals, I have a negative x plus 10. So I have a negative x slope. The next one, I have 2x plus 2y equals 20. I'm going to get y by itself, so I'm going to take my 2x away from both sides. So I now have 2y equals negative 2x. Can't combine my 2x and my 20. Plus 20. But I have 2y, so I need to divide this by 2 and all of this by 2. I get y equals negative 2 divided by 2 is negative 1x. 20 divided by 2 is 10. These are the same line, which means they have infinite, so it doesn't work. Next one. So we have to do the same kind of thing. We need it to be in slope-intercept form. Because there's not a lot to do, I need to take x from each side. So I'm going to have minus x, minus x. Sorry, not plus. minus x and minus x on this one. So my top one, I'm left with y equals negative x plus 10. Bottom one, y equals negative x plus 12. So I have the same slope, different y-intercepts. That means no solution. F. I have a slope of 2 and a slope of 3. Different slopes mean one solution. For G, I need to get into slope-intercept form. So I'm going to rewrite them. I have y minus 2x equals 2. I'm going to add 2x to each side, giving me y equals, I'm going to put 2x first, so it's in slope-intercept form, plus 2. For the next one, I have y plus 2x equals 10, minus 2x from both sides. Y equals negative 2x plus 10. So these are my two equations. They have different slopes. Different slopes means one solution. H. I only need to do a little bit of work on the first one because the second one's in great form. So I need to minus an x. This gives me negative y equals negative x plus 9. Because this is negative, I need to divide by a negative 1. So now I have y equals x minus 9. They have the same slope, but they have different y-intercepts. So there is no solution. And the last one, I. Looks like we're going to have to do some maneuvering. Have x plus 2y equals 10. Minus x from both sides, leaving us with 2y equals negative x plus 10. Need to divide both sides by 2. So I have y equals negative a half x plus 5, because half of 10 is 5. For the other side, I have negative 4x minus y equals 2. I need to get x to the other side so it's in slope-intercept form. I now have plus 4x plus 4x, negative y equals 4x plus 2. Dividing both sides by negative 1, so I have a positive y, negative 4x minus 2. So I have different slopes. Different slopes means one solution. So these ones you did not have to plug anything in, because we were just wanting to know if they have one solution. The next two we need to solve because it says solve the system of equations. So that's where we're going to substitute. We're going to plug stuff in. So I have half of an x plus 6y equals 12, and y is equal to x plus 15. So we're going to plug that in. I have half x plus 6, x plus 15. All of that is equal to 12. Because I have a parenthesis, I need to distribute. So I now have half x plus 6x plus 90 equals 12. I need to combine like terms because I have two x's over here. I have a half of an x and I have a positive 6x, which gives me 6 1/2 x plus 90 equals 12. I need to get my variable by itself, so I'm going to subtract 90 from both sides. 6.5x now equals, that one I'm not 100% sure on, so let's see. 12 minus 90. 78. Negative 78. I need x by itself, meaning I need to divide by 6.5. So x equals negative 12. So I know what x equals. I need to figure out what does y equal. Well, to solve for y, we need to plug in what we know, still using substitution. So we know that x equals negative 12. Well, we have this equation right here. Y equals x plus 15. I'm going to do it right here. Y equals x, which is negative 12, plus 15. So if I were to plug that in, I have negative 12 plus 15. If you know it in your head, do it in your head. Is a positive 3. So your answer in the boxes that you fill in, it's like x and then there's a box, y and there's a box, is going to be negative 12 and 3. For your explaining, you're probably just going to have to type this all out and make it lined up, whatever the problem is. Very similar problem. Plugging stuff in. So we have 3x plus 4y equals 36. And y is equal to half of an x, negative half x plus 8. We're going to plug this in right here. 3x plus 4 times negative a half x plus 8. All of it equals 36. There's parentheses, so we need to multiply. I'm going to rewrite my 3x. 4 times a negative half is negative 2x. 4 times 8 is 32. I'm going to combine my like terms. I have 3x and I have negative 2x, which gives me x plus 32 is equal to 36. I need x by itself, so I need to subtract 32 from both sides, giving me x equals 4. Well, now that I know that x equals 4, we're going to substitute this value in for x. So we have y equals negative 1/2 times 4 plus 8. So negative a half times 4 gives us negative 2 plus 8. Y is equal to 6. So you're going to have the two little boxes. I don't remember exactly what the problem looks like, but it's something like that. And you're going to fill them in. So we have x is equal to 4. Y is equal to 6. Next problem. Here's a graph for one of the equations in a system of two equations. So system of two equations is like these front pages. The solution to the equation is 6, 2. Select all the equations that could be the other equation in this system. You can do it a couple ways. You can graph each line and see that they go through this point. You can find out what is the line of this equation and see. Any way works. So if we're going 1, 2, 3, 3 with this first one, it's going to be purple. My y-intercept is 0 because it's not listed. And my slope is negative 3. So that means I go down 3 over 1. So this is my line. Does it cross here? No, it doesn't. Next, we're going to have this color. My y-intercept is 6, so I'm up here. And my slope is down 3, right 2. down 3, right 2, down 3, right 2. Whoops, right 2. Connect my points. Remember, we are looking for the one that goes through this point right here. Next, I have this kind of color. My y-intercept is 3, and my slope is down 1 over 6. So down 1 over 6. Right through that point. So this is one. Next, I have green. My y-intercept is -1. And my slope is up 2 over 3. Up 2 over 3. Up 2 over 3. So it is not going to cross. This one has no solutions because they are parallel. Next we have magenta. So our y-intercept is -1, but my slope is up 1 over 2. So this one does cross right there. So that one works. And last one will be orange. Its y-intercept is -2, and its slope is +4. So that means up 4 over 1. Looks something like that. So the two that did work were these two. Next one. What is the solution? This is just a repeat of what we've been doing. All you're doing is solving for x. So we need to get our x's together on both sides. So on this side I have I have 3 x's plus 1 more, so I have 4x plus 30. On this side I have 2x plus 5 more, so I have 7x. But I also have these two constants, 10 and 2, so plus 12. I need my variables together. Since 4 is smaller, I'm going to subtract 4 from each side, giving us 30 equals 3x plus 12. Well, now I need my constants together. So minus 12 minus 12, giving us 3x equals 18. Divide by 3, and x is equal to 6. This next problem, these next two are 2 parts. I don't remember if it's 1 page on your test or 2 pages. Lynn and Han's family spend or provide money for their school lunches. Han starts with $100 and spends $15 each week on lunch. Okay, so Han, he starts at 100 and he takes $15 away every week. Lynn starts with $25 and doesn't spend any of it, and her family adds $10 each week. At the end of 4 weeks, who has more money? So we're going to plug a 4 in for our W. So on our calculator, if you type it just like you see it, 100 minus 15 times 4. Han has $40. Lynn is 25 plus 10 times 4. Lynn is at $65. So at the end of 4 weeks, who has more money? Lynn has more money. After how many weeks will Han and Lynn have the same amount of money in their lunch accounts? This is where we set their two equations equal to each other. So we have 100 minus 15w equals 25 plus 10w. We need our w's together, we need our constants together. Because this is negative, the opposite of negative would be a plus. And I'm going to do two steps in one line, just like we do in class all the time, due to space. So I'm going to add 15, and I'm going to, because I'm getting my constants over here, or my variable here, I'm going to get rid of this constant. Minus 25, minus 25. This, we have 100 minus 25, which is 75. 15 minus 15 is 0. 25 minus 25 is 0. And then we have 10 plus 15, which is 25w. The opposite of multiplying by 25 would be to divide. And 75 divided by 25 is 3. After how many weeks will Han and Lynn have the same amount of money in their lunch accounts? After 3 weeks. It doesn't ask how much money, so you don't need to solve anymore. You're done. This problem, Diego has $11 and begins saving $5 each week towards buying a new phone. So Diego starts with $11. And then he begins saving $5 each week. So he's adding $5 every week for a new cell phone. Lynn has $60 and begins spending. So she's losing money. She's taking it away. $2 each week. Is there a week where they will have the same amount of money? So we need to set these two equal to each other, just like we did right here. So I have 11 plus 5w is equal to 60 minus 2w. Because this is a negative 2 or a minus 2, I'm going to do the opposite of that one because it's going to be adding. So plus 2 plus 2. And because I'm getting my variables over here, I need to get rid of my constant. Minus 11, minus 11. So I get 11 minus 11 is 0. 5 plus 2 is 7w. 60 minus 11 is 49. Now we have 7 times w equals 49. The opposite of multiplying would be to divide. So w equals 7. So 7 weeks. Next part is how much money will they have? So I need to plug in my known value for w. And I can do it in either of them. I can do it here, or I can do it here. So Diego is 11 plus 5 times 7. Lynn is 60 minus 2 times 7. When I type them on the calculator, I'm going to get the same thing. 11 plus 5 times 7. I get 46. Now if I do this one, 60 minus 2 times 7, I get 46. So they will both have $46 after 7 weeks. Last set of questions. 60 people attend a game night. Everyone chooses to play chess, a 2-player game, or everyone chooses to play chess, a 2-player game, or cribbage, a 4-person game. All 60 people are playing either chess or cribbage. So this aisle is not on, or row is not on your test. But I want you to know that all of these are 60. So this number plus this number should be 60. And we know that chess has 2 players. So chess is 2x. And we know cribbage has 4 players. So cribbage has 4y. So if I have 8 games going on, and there's 4 players per game, I have 4 times 8, which is 32 players. How many more players can I have? Well, 60 minus 32 is 28. That means I can have 14 games going. Because if I have 14 games, 2 people per game, that's going to give me 28 players. So if I have 12 games, that's a total of 24 players. That means I need 36 players, people playing cribbage. Well, I know 4 times 9 is 36. So if I have 15 and there's 4 per game, that means all 60 players are playing cribbage and I have 0. If I have only 2 games of chess, that means only 4 players, which means I'm going to have 56 people playing chess. That one I'm not 100% sure on, so we're going to figure it out. 4 times what's 56? So I'm going to do the opposite of dividing. 56 divided by 4 is 14. I should have known that with 15 right there. This next one is blank, I don't know. So we fill in our table, we have 14 and 0, then 9 and 14. There are 3 more cribbage games being played than games of chess being played. How many of each game are being played? So I know that I have these 2, and it equals a total of 60. So 2x plus 4y is equal to 60. But this is saying I have 3 more cribbage games being played. So that means there are 50 athletes signed up for a neighborhood basketball competition. The players can select to play in a 6-player game, which is 3-on-3, or a 2-player game, 1-on-1. All 50 athletes sign up for one kind. So that means this is all 50. No matter how many sign up for each, it needs to equal a total of 50. So if only one 2-player game is going on, that means only 2 people. So we still have 48 people that need to be playing. This is 6 players, so 6 times what's 48? 6 times 8 is 48. Number 2, we have one 6-player game, so that's 6 people. So our 2-player games need to equal a total of 44. So something times 2 equals 44. 22 times 2 is 44. Next, we have 4 2-player games. Well, if there's 4 games of 2 players each, we have 8 players in total. That means we need 42 6-player games. 42 divided by 6 to figure out how many games is 7. If I have 4 6-player games, that means I have 24 players in use. So I get 26 for 2 players. 26 divided by 2 is 13. So our boxes are filled in. If the neighborhood holds 13 total games and all 50 athletes are participating, how many 6-player and how many 2-player games are there? So let's see. This is a total of 9 games, 23, 7, 8, 9, 10, 11 games. So we're really close here. So what if we take 1 game away from here? So we have 6 games. 6 times 6 is 36. So that means we have 24 2-player games. So that would be 12. So if I have one 2-player game, that's 2 players. 50. 6 6-player games is 36 players. Oh, gives us 14 left over. I'm like, what am I doing wrong there? So that would be 7 2-player games. And 6 plus 7 would be our 13. So we would have 6 6-player games and 7 2-player games. And you may have noticed that I did not finish this one because you can do guess or check or you can create an equation, but I'm not going to go over it because this question's on the test, so I really can't do that.